Effective Live Regions to Convey the Loading State of Your Web App by Ross Mullen. 10 Years of Alibytes 2022.
It used to be so simple. The user changes an option on a page, submits the page, and a hard refresh occurs. This hard refresh triggers the screen reader to identify new content and begin outputting it orally. Then screen reader apps came along. The hard reload of page content became replaced with the page dynamically reloading parts of the content whilst not affecting the whole page. Because no hard reload takes place, the screen reader has difficulty understanding what's been changed. And this is where we are today. Several common conventions are used to visually describe something is happening. CSS animations and animated icons are all used to describe a process that is taking time, affecting the user's workflow. This, however, is only conveyed visually, the animated icon giving something for the user to look at. Ordinarily, this probably isn't a problem for a screen reader user. Most people today have fast internet connections and any page changes are instantaneous, where the user won't notice any delay. The delay between the user clicking a button to initiate an action and the content loading is often quite trivial. But is this really good enough? Is this a good enough user experience? To think, in most cases, for most of the time, this loading behaviour doesn't need to be described. No. We need to design for all potential scenarios, one of which a screen reader user with poor internet connectivity. People in remote parts of Australia and indeed other countries around the world will have slower internet connections, which will increase the time for new content to load. Because of this is where the technique of using ARIA Live Regions can begin to be used effectively to describe the loading state. But what exactly is a live region? A live region is a container which enables screen readers and assistive technology to provide audible feedback. The way a live region works is a container on the page is marked up with an appropriate role, where content is injected into the live region which triggers the screen reader to output whatever is in the container. There is no dedicated ARIA authoring technique for describing the loading state of a page, as it's not necessarily that difficult to create, but there are two possible approaches to take. Use a live region with a role of status or a role of progress bar. Conveying a loading state is presenting advisory information, and so a role equals status is chosen to reduce the level of urgency the text is outputted by the screen reader. But why not use progress bar? Progress bar is more suited to when we know how much of the content remains to be loaded and can update accordingly. If you're familiar with app progress bars, you've seen the 1 minute remaining indicators, which often aren't particularly helpful and jump around. When a remote call to an API is being made to load new page content, there is a lot outside of our control, and it's tricky to identify how much of the content is remaining to be loaded. Besides, the simpler approach of a live region with role of status yields far better compatibility and common behaviour between browsers and screen readers. Adding the text loading to this container would be sufficient to trigger the screen reader to output the text, but this is where it becomes tricky. A live region only triggers the screen reader to announce new text changes. The first time text is injected into the region, this will be outputted. Using the word loading triggers the screen reader to output loading, providing an oral indication content is in a transition state. However, if there is a delay in the content being loaded, it quickly becomes noticeable that a single outputted instance of loading is insufficient. Consider the case where a user may miss the initial output. What then remains is an unusual state where nothing is being announced, yet the screen activity is doing something or waiting on something. To address this, the text in the container needs to change to cause the screen reader to announce new content. We could use ellipsis and alternate between 2 and 3 ellipses. This is enough to trigger the audible change, but the user experience is not great. Along with the text loading, the user also hears ... or ... for the two ellipses. It works, but it's a bit clunky. To overcome this minor inconvenience, we could try and retain the loading text but hide the ellipsis from the screen reader. But using CSS to hide the ellipsis is also insufficient to trigger a change. These are rendered as invisible by the screen reader, and we're ultimately back to our original position, where to the screen reader at least nothing has changed. To trigger consistent screen reader output of a single unchanged word, the text container must be reset repeatedly. For a good screen reader user experience, it isn't enough to merely change several characters. Using the setInterval method in JavaScript, a function is repeatedly called which toggles the container text using the inner HTML property. Every second the text changes from loading to empty and back again, enough to trigger a screen reader to output loading repeatedly. The frequency of audible output is set in this instance to every second, which can become frustrating in itself. 2 or even 3 or even 4 seconds could be a good compromise to describe to the user that a transition is taking place but not become overwhelming. When the content has loaded, the interval time is cancelled. This technique has very good coverage amongst JAWS, NVDA, VoiceOver, both macOS and iOS, and TalkBack, where all combinations perform uniformly and consistently. On screen is a table showing the browser's Edge, Chrome, Firefox, and the devices iPad Air 2, iPad Mini, iPhone 7, Galaxy Tab A7, and macOS, displayed in rows with the screen readers JAWS, NVDA, VoiceOver, TalkBack, and Narrator as heading columns, describing the compatibility of all of the combinations. There are green ticks in each column except for Windows Narrator on Firefox, which shows a red cross indicating incompatibility. Loading states described orally can work well to enhance the transition of a user's workflow or the path of an application. However, the live region role of status alone is insufficient to repeatedly convey the state, and so this must be combined with a small amount of JavaScript to destroy and recreate the static text node in the DOM. Increasing the timeout from 1 second to 2 seconds or even 3 seconds is preferable to reduce frustrating a user with too much oral feedback. Check the example on GitHub at github.com/canaxes, CANAXESS/app-loading-pattern, along with a runnable example, source code, and a full compatibility matrix against the popular browsers and screen readers. If you're interested in working together and improving your digital accessibility, reach out to us at canaxes.com.au, that's CANAXESS.com.au, or email me at ross.mullen@canaxes.com.au.
Celebrating 10 years. Alibytes 2022.